Here's problem 10. It's asking for the distance between this point and this point. Now, we simply would use the distance formula as soon as we see that. Now, if you go back and you look at the video for problem 8 here in this section, I showed you how it works, how really you just plot this point, and then you make a right triangle and use Pythagorean theorem, which is what this distance formula is. And I explained that in problem 8 if you want to go back and see that. But right now what we're going to do is we're just simply going to do the change in our x's squared plus the change in our y's squared. We're going to use that formula. That's going to give us the change in our x's. Well, look at this. Negative 11, negative 9. Now I can see the difference between those is 2. So I'm going to do 2 squared. Negative 11 minus negative 9 is simply going to give you negative 2. But when you square a number, 2 squared and negative 2 squared are both going to give you a positive 4 no matter how you do it. Changing the y's. So how far apart are negative 3 and positive 1? One day the temperature is negative 3, the next day it's positive 1. Those differ by 4. So the change in y's is 4 squared. Again, you could do negative 3 minus 1 or 1 minus negative 3. The difference between the numbers is 4, and you're going to have to square it. Sometimes students forget to square it, so be careful you don't make that mistake. 2 squared is 4. 4 squared is 16. And so the answer here is the square root of 20. Now I know that that's approximately 4 times 4 is 16. 5 times 5, 25, too much. This answer, when we do it, it's going to be approximately 4 and a half, I believe. I think the square root of 20, if my memory serves me well, about 4 and a half there. There's problem 10. Simply, you're just looking at the difference between the x's squared plus the difference of the y squared, put them together, and then simply use the calculator to take the square root.